With the climate change conference happening in Paris this week, our country, our province, and our city will be thinking about opportunities to reduce greenhouse gas emissions. We and our children will be looking for ways to feel good about making a difference and positively affecting climate change. Our community of Abbotsford is termed the city in the country because much of our city includes agricultural land, and agriculture is important to our economy. How does our agriculture impact climate change? And is there anything that we can do? We need to keep our head in the sand. We need to pay attention to our microbes, particularly our soil microbes, because they are the ones producing the greenhouse gases. We need to understand the science in its proper context so that we can make good decisions that will mitigate climate change. In agriculture, nitrous oxide, or laughing gas, is the greenhouse gas of greatest importance, both because of how much is produced and because there is more that we can do to reduce it. It is produced during at least two processes where the forms of nitrogen in soil are changed by the microbes. Nitrous oxide emissions to the atmosphere increased dramatically since nitrogen fertilizer was invented. In fact, 60% of the world's nitrous oxide emission now comes from agriculture. When we add more nitrogen to our soil than is required by the plants for growth, we can expect more nitrous oxide emission. This is even more true when we apply manure because we're adding carbon with the nitrogen, which also changes the soil atmosphere for the microbes. As the nitrogen surplus increases, the nitrous oxide increases all the more. We learned this 20 years ago. Research in Europe shows that nitrous oxide emission from agriculture can be reduced by 30 to 75% simply by balancing the nitrogen we apply to our soil with the nitrogen taken up by the plant. In Abbotsford, of the calculated greenhouse gases coming from agriculture, 2/3 of it is nitrous oxide and 1/3 is methane. Most of the nitrous oxide comes directly from soil after we apply manure or fertilizer, and some of it is produced indirectly from ammonia emissions from animal barns and manure storages. We learned this 20 years ago. Nutrient management planning to optimize the nitrogen in manure and fertilizer for our crops is the simplest way to impact climate change. This has other benefits as well, including reduced potential for air and groundwater pollution. Another way to positively impact climate change is to balance the nitrogen that we feed to our animals with the nitrogen that they need for growth. This reduces ammonia emissions as well as nitrous oxide emission when the manure is applied to the soil. We also learned this 20 years ago. You may ask, what about anaerobic digestion that captures all the methane? That's an interesting question, and guess what? We learned about that 20 years ago as well. Methane from manure storage makes up about 16% of the methane produced from agriculture and less than 5% of the greenhouse gas emissions. Anaerobic digestion doesn't reduce the emission because of leakages and the need to import other organic wastes for digestion. Germany, in spite of its thousands of digesters, learned this several years ago. If we want to make a positive difference for climate change, we need to keep our head in the sand, and we need to learn the science in its proper context. In a circular bioeconomy, we need to recycle our nitrogen in more effective ways to make a difference with climate change. What better time to start than now? What better place to start than right here in our own community? Let's work together to make a positive difference for climate change. 2015 is the International Year of Soils, a year that we celebrate how important our soil actually is. My name is John Paul. I'm a professional agrologist and a soil scientist. Thank you.